All right. That was dumb. All right, so we start all over again, record, 3, 2, 1, boom. All right, so today, exponential growth and decay. There's the equation for exponential growth and decay. And, we'll make sense of it as we move on. Let's start with the question and then refer back to the equation with its separate parts. But for sure, you all have seen this before, so once I just give you all a little push, ignition on, y'all can do the rest from there. But let's take a look at it. Example 1, $7,000 is placed in a savings account with an annual interest rate of 3%. If no money is added or removed from the account, which equation represents how much will be in the account after 7 years? So this is from Delta Math. This question was multiple choice, but I just removed the choices so that we can just concentrate on the question and how to get the answer from there. So $7,000, let's start with that. So we're going to write an equation that represents after 7 years, or T years, okay? Well, there we go. If we refer to the format of the equation, looks like T is going to be up there, so we'll use that to help us. Well, 7,000 is placed in a savings account, annual interest rate of 3%. Annual interest rate. So what that means is, interest rate means every year, however much you have in the account, you're going to add 3%. Yes. So what that means is we'll multiply it by 1.03, okay? If you multiply 7 by 1.03, what do we get? 7,000 times 1.03. You get 7,210. So that is a 3% increase. 3% increase. Notice I put 1 in front and I added 3% to the 1. So that 1 is necessary. Suppose I just put 0, okay? Just 0% increase would mean 1. So 0% increase is multiplying by 1. 7,000 times 1, what do you get? You just get 7,000. So you have to add 3% to the 1 when we multiply to the 7,000. And the way interest rate works is, well, then if you have 7,210 years in T amount, at year 0 you have 7,000. After 1 year, apparently you have 7,210. Well, what do you have after the next year? Well, that is 3% increase from 7,210. So, you multiply again by, every year you're just multiplying by 1.02. Every year you're just multiplying by 1.02. I'm sorry, 1.03, right? 3% increase. $7,426.30. So don't just copy everything down. Just try to understand the idea. You're just multiplying 1.03 at the end of every year to the amount you have. So every year is going to keep increasing. Just keep on increasing by 3%.
Do you know if you go to someone's clap out at 1:30, you kind of have
I have no idea.
some?
I don't know or care. I'm sorry. Have a good day. Yeah. 7,000 times 1.03. And so how do we make an equation that represents, here it is, T. Here we go. That's the equation, okay? 7,000 is your starting amount. Add 3% to 1, and then T is how many years have passed. So this is the equation, okay? Maybe I didn't need to explain all that. But the idea is it's increasing 3% every year. So what do you multiply by? 1.03 for every time. Similar to what I initially gave you, but that's very similar, but that's specific to percent growth. All right, here's another equation. Another equation we have to find from an example. In a lab experiment, the population of 250 bacteria is able to triple every hour. Which equation best matches the bacteria in the population after 8 hours? So yeah, an equation, but not a function, because we know what the t is. T is 8. And apparently they're not using y, or we'll start with y, okay? So following the format, the starting amount is 250. There goes something in the parentheses, and instead of t here, we're going to put 8, because we know what the time is. So let's kind of use the choices this time. It's definitely not question A, because it starts with 3. No, you want 250 in the beginning. I mean, D looks like kind of crazy, but it might be right, you know? So let's maybe make a table, you know? Maybe this is helpful. Hours on the left, the number of bacteria on the right. So at hour 0, you have 250, right? Then hour 1, it triples. It triples. So that means, that literally means it's multiplied by 3, y'all. So you get 750, I think. Yeah. And then it'll keep on doing that every time. So which of those remaining 3 represents triple? I think it's this one. Triple, but how many times do we triple? 8 times, because every 1 hour it triples. So if 8 hours have passed, it's tripled 8 times. So this is the only one that represents 8 hours. But maybe this C is confusing. It's because, well, there you got the 1. So aren't you supposed to add the 3 to 1? Well, no. You only add to 1 if you're just given a percentage increase. Okay? If you're given a percentage increase, you add it to 1. Okay? So moving on. Here's another type of example. Given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. Well, it's as simple as this. We start with 18, okay? Look at the equation, try to understand the equation. You start with 18 and you multiply by 0.914 every time x passes. So do you think if you multiply by 0.9, is it going to increase or decrease? Try it out. 18 times 0.9, I got 16.2. And if I multiply by 0.9 again, it just keeps on decreasing. So there's the thing. This number in the parentheses, less than 1, if you multiply by a number less than 1, you'll decrease. So this is, it's not a growth, it's decrease. And what percent does it decrease by? What percent? So change that to decrease. How much is disappearing every x, every hour, or whatever this x is? 1 minus 0.914, you know? How far away is 0.914 away from 1? I'm just going to do 1 minus 0.914. I get 0.086. And then when you move the decimal to the right, you get the percentage. 8.6 decrease every time x passes. Percent, okay? So as simple as the number is less than 1. And how far away is that number less than 1? Apparently it's 0.086 away from 1. So move 2 decimals to the right, 8.6% decrease. And all right, last one. Find the equation of the exponential function represented by the table below. This is a good one. So it is an exponential function, so we're going to have something in the form y equals a1 plus or minus r. Wait. I mean, you can also see the format as this, you see? 2 numbers and the second number is raised to x. You know, this is a more general form of this growth or decay equation. So if we have that table and we know it's exponential, we can find that equation. We can find what a and b is. Well, look at this. At 0, y equals 4. So what that means to me is the a is 4, okay? And then the b is just how much is multiplying each time. How much multiplies from 4 to 12? What's multiplied? 3. And does that pattern stay true every time? 12 times 3 is 36? It is. And again, this is multiplied by 3. Times 3. Let me put some space for that. Hello. Take a look at that. She is not here yet or at all, so we can hold on to that. So there we go. If it's times 3 every time, we found our b is y equals 4 times 3 to the x. That's your equation that represents whatever x is, we'll find what the y is. If we're just tripling each time, as the table is apparently implying, that's the equation. So it just gets a little confusing when you're dealing with percentages. But you'll figure it out. Y'all are smart. If you care about it, you'll figure it out. And you'll ask me. And if it's important to you, you'll figure it out. But, you know, this is truths. There's no lies here. So if you're interested in figuring out this problem, the problem to whatever this stuff is, you got it. And they live happily ever after. Amen.